Welcome back, Algebra 1 students. Happy Friday. We are going to continue with a review of factoring a GCF from a polynomial. So that's all of our examples for today. Factor the GCF from a polynomial. Before we jump in, remember that factoring means we write as a multiplication problem. I should have put end quotes on there. I'll add those now. Okay, write as a multiplication problem. Answers should be in the form GCF parentheses leftovers. So that's what we're working on today. Let's get into our examples. First one, I hope, is pretty easy. The first thing we need to identify is our GCF. Hopefully you can look at these and know that the only thing both of these could be divided by is a 2. We cannot divide them both by u or v because they don't both have a u or a v. Our GCF also goes outside those parentheses that we make. Inside the parentheses would be our leftovers after we divide. So 6v divided by 2 is 3v, plus 2u divided by 2 is 1u, or just u. If you put the 1 there, that's fine. If you don't, that's fine. That would be our factored form. Again, with all these videos, pause them, rewind them, write down questions to email me. Make sure you're doing all of those things to make sure you really are understanding this. All right, second example, we take it up a little bit. We have 3 terms this time. Hopefully you can see that all of these numbers, 20, 40, and 70, are divisible by 10. That's going to be their GCF for the number part of it. So then we would just need to look at the variable part. So let's start with the x's. Okay, we've got x squared, x to the first, and x squared. So the most that they could all give up at the same time to keep it equal would be 1x, or x to the first. Then we look at the y's. This one's got 5y's, 5y's. This one only has 4y's. So that means that the most they can all give up at the same time would be 4. If it were any more than that, the last one wouldn't have enough to give. Okay, so that's our GCF. The other place we write that is outside our parentheses. Inside the parentheses, we are going to put our leftovers. So 20 divided by 10 is 2. Remember, when we divide the same base, like x over x, we subtract their exponents. So 2 minus 1 gives me 1, or x to the first, or just x. We'd also get y. 5 minus 4. In the middle, 40 divided by 10 is 4. The x's cancel out completely. And we do still have a y. The last term, we would get 7x because the y's would cancel out completely. And then we can end our parentheses there. There is our factored form. Nothing that's left in our leftovers inside has anything in common anymore. At least not amongst all 3 at the same time. All right, let's get on to example 3. If you're not sure about what the GCF of the numbers is going to be, you could write your prime factorization. Like the prime factorization for 35 would be 5 times 7. For 14, it would be 2 times 7. And for 28, it would be 2 times 2 times 7. So the only number they all have in common would be the 7s. So I know I can divide all of them by 7. Then we look at our U's and V's. They do look kind of similar. For the U's, this last one limits us. It only has one U. This one has 3, this one has 2. But they all have to be able to give the same amount at the same time. So just one U. Same with the V's. We're only going to be able to use one V, or V to the first, because the one in the middle and the one on the end each only have V to the first. We write that GCF outside of some parentheses. Inside we put our leftovers. So 5UV minus 2U squared, V's canceled out, minus 4U and V canceled out. There is our final answer. If you have questions, concerns, or confusion, make sure you write those down and send them to me in an email or a message. Let's go on to example 4. Looking at example 4, I hope you can see that 7, 10, and 7 don't have any factors in common. If we were to make our lists, 7 is prime, 10 is 2 times 5, 7 is still prime. So our GCF for the number part would have to be a 1, which we haven't usually been writing, but we can still factor out a variable GCF. Now looking at these, my first two terms have x's, but my last one doesn't, so my GCF can't include an x either. So then I go and I look at my y's. How many y's could each of these give up at the same time? Well, this one has 6, that one has 5, that one has 5, so I'm going to say y to the 5th is what I would be able to factor out. They could all give y to the 5th. All right, when we do that, our GCF goes outside our parentheses, and inside we put our leftovers. So for our first term, we know there's going to be 7x left over. And if we subtract our exponents, we get y to the 1st, just y. Plus, again, 10x, that's not changing. The y to the 5ths would cancel out completely. Minus 7 isn't changing, but again, the y to the 5ths would totally cancel out. And this would be our factored form. All right, we've got one more example to do today. Here it is. This is one where it might be helpful for you to write out your prime factorization, like making your factor trees and all of that. So we can do that together real quick. 63, I could break into 7 times 9. 9 breaks into 3 times 3. So my list there would be 3 times 3 times 7. 81 would break into 9 times 9, with both 9s breaking into 3 times 3. So we would have 3 times 3 times 3 times 3. Let me make a little more room up here so I can fit the other lists. All right, I scooted those lists up a little bit so I've got some space. 54, we could break into 9 times 6, 3 times 3, 3 times 2. So we have 2 times 3 times 3 times 3. Last up we have 36. So So erase one of these down here. 36 could break into 6 times 6, with each 6 breaking into 2 times 3. So 2 times 2 times 3 times 3. Okay, we've got all those lists. So what's in common? Well, on all the lists, I see 1, 3. On all the lists, I see another 3. And then I don't see anything else that all the lists have in common. So I know part of my GCF is 3 times 3, which would be 9. Then we go to look at the variables. Looking at the variables, they don't all have the same variable at the same time. So we've got a couple terms that have x's, but not all of them. We have a couple terms that have y's, but not all of them, which means 9 is the only part of our GCF. So 9 goes outside those parentheses that we make. The leftovers go inside. So we have 7x cubed plus 9y cubed minus 6y squared minus 4x. None of those terms in the parentheses can be combined, nor do they all have anything in common. So that is our final answer. Okay, like yesterday, you should look for that Google form as your assignment and get that completed. Make sure you are emailing me any of your questions, and have a wonderful weekend.